Okay, everybody. We're live on Firebase After Hours, and I am super excited to see all of you on the stream. So if you are on the stream, say hi, tell us where you're from, and I need to mute myself. Okay, right. Too many windows happening at the same time. Great. So if you're watching, tell us where you're from, where you're dialing in from, and also maybe tell us what is your favorite beverage. So if you can tell what this is, it used to be a flat white. It's empty now. So I'll have to resort to water for the rest of the stream. But I'm curious what you people like to drink. And one more thing before we get started. This is the Firebase channel, so let's be nice to each other. Let's be excellent to each other. If you see something that you like, give us a thumbs up. Give us any heart emojis that you have in your emoji bar. Give us your ta-da emojis. And if you have anything that you don't like, reach out to us directly. Tell us how we can improve. If you see something that you want to bring up, tell us as well, and let's just be excellent to each other. And with that, I'm going to bring on Nohe. Here he is. Hey, Nohe, how's it going?
It's going. How are you doing?
I am good. So it's so good to see you, man. I mean,
Yeah.
I've done 2 live streams solo now, and boy, it is hard.
Yeah, I feel like you gotta be a little bit, committed to talking to yourself for like an hour and a half, especially when I live stream, because usually it's just me, right, in the room
Yeah,
by myself and my like 3 Twitter followers that are just bots, right? So I could sit there and talk for forever just to myself. And if you come into the office and nobody's in there, I'm usually just doing the same thing, just sitting there.
yeah, yeah, exactly. All right, so what are we gonna do today?
That's a great question. I was hoping to ask you. I walk in the morning and I open it up and I have this email from Peter. I'm like, I gotta read that. And then like my check is bling 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 bling. I don't know about you, but when I'm in a chat room, it's hello. It is. I have too many chats, so I hear the pings. But I have a hard time figuring out where they're coming from sometimes.
Yeah, you got to mute them.
Yeah, it's
And then you need to complain to people. Why is nobody talking to me? Right? Okay. Yeah, so I think so we're gonna switch roles. So in the past couple of episodes, we've mostly, I've grilled you and you did the work, you did the coding, and I was able to just relax and sit back and just ask the uncomfortable and hard questions. So today we're going to do it the other way around, and you're going to ask all the questions, I hope.
yeah. I'll try
And I
to.
got to
And
do the coding.
chat, back me up here.
Okay, so we're going to do Vertex AI, and maybe to get us started, let me first bring up my screen and let me find my mouse cursor. So that is one of the biggest challenges here. Okay, great. So hopefully everybody can see my screen. I can see my screen. Now, can you see my screen?
I can.
Okay, amazing. Cool. So, sorry. Then, give me a second. I just noticed that my chair is eating up the cable of my microphone, which is not good. Okay. So, Noe, what is Vertex AI?
Vertex. I didn't know it was going to be a quiz, Peter. I would have studied. Vertex AI is Google Cloud's offering of a bunch of models and training to help boost your AI, right? So if you wanted to deploy Gemma, they have this thing called like Model Garden, and you can deploy it to a hosted endpoint that will run 24/7, handle setting up permissions, all this other stuff for you. If you want to talk to our latest models, you could do that through the multimodal chat interface. And then if you want to train your own models, we have Colab Enterprise notebooks where you can attach a GPU to your Colab instance and then run it longer than the Colab website. So I think like the runtimes are infinite. So hypothetically, if you wanted to build a model that took like 2 years to train, you could do that. I would be scared if I was training a model for 2 years that it would just fail. Yeah,
That must be expensive.
probably. Yeah, I haven't done a price estimate, but I assume if you're running it for that long, it's probably gonna cost and take some time. But you can also have the serverless aspects of talking to Gemini. And I assume that this Vertex AI and Firebase, now generally available, is referring to the serverless Gen AI endpoints like Gemini and Palm. Is Palm still around there? Has that been gone?
It's a good question. I don't know, but yeah, I think these days Gemini is definitely the more interesting and up to date model, right?
It's also cheaper too now, right?
Yeah,
It's more affordable. Yeah.
yeah. Okay, so and what about Vertex AI and Firebase? So we've got this blog post here that we posted a couple of days ago, and Miguel, who's one of our product managers, talks about how this is now GA, right? So it's generally available. People can use it in production, and so maybe let's have a look at this chart here and try to understand what Vertex AI in Firebase is. So on the left-hand side, we see a phone and a browser. On the right-hand side, we've got the Vertex AI Gemini API, and in the middle, we've got Firebase. So how does that help us? What's your way of explaining this, Nohe?
So I believe when you have a use case where you want to contact Vertex AI from your client app, you could go through a few different ways, right? You can write your own serverless endpoint that can then have not OAuth, but auth N and auth Z set up on top of it, as well as a few other things. Deploy that endpoint to the cloud, pay for the serverless invocations, things like that. Or what you could do is you could go through Firebase and just talk directly to it, and we handle all that extra backend stuff for you. So I assume that this is some sort of Firebase middle layer in between the two that handles auth N and auth Z. That's my assumption. I actually have not used the Vertex client SDKs all that much.
Mm-hmm.
So I feel very quizzed right now.
Okay, yeah, I think that's a really good explanation. So what we want to do today is to build something on top of Vertex AI in Firebase, and I'm going to show something that we already have. So those of you who have watched some of our solution guides might have seen this before. So this is a chat application, but instead of being just a regular chat application, it is a text adventure. So I don't know about you, but I've played text adventures in the past. I'm a big fan of The Hitchhiker's Guide to the Galaxy. And here's a fun story. Before I even read the book, I played this text adventure and actually it was on a computer, right? So when I was a kid, computers were not connected to the internet because there was no internet, or not the internet as we know it today. So And I always wanted to build this myself, and you can now download the a free version of that, or you can play it online. The BBC has an amazing version of the Hitchhiker's Guide to the Galaxy that you can play online. So the way how it works is, and here's a replica, and it works like that. You see a text of what is happening. So here it says, you awaken to a blaring alarm, a synthesized voice crackles through the static. Intruder alert, hyperspace core destabilizing, eject procedure initiated in T minus 30 seconds. So that's not a lot of time here. And now you need to do something. Investigate the source of the hull breach, check the ship's computer for a status report, or take the easy way out and eject from the escape pod. So down here, we've got a chat field, and I can now type in something. So Nohe, what do you think we should do?
Investigate.
Investigate. You stumble out of your quarters and into a dimly lit corridor. The ship groans and shudders around you, alarms blaring, smoke pours from a maintenance hatch ahead. Possible actions: open the maintenance hatch and investigate the source of the smoke, head to the bridge, find an escape pod, and eject. Oh, and now we get the inventory. So what we have. That's really nice, yeah. So
if I said like put on a suit, would that work?
Yeah, I think so. You put on a suit.
Oh, okay.
Yeah. Okay.
Right.
How much time is left?
Oh.
Let's see. Let's see if it keeps time. Oh, what? 20 minutes. that is interesting. Oh, because we have the suit on now. All right, so head to the bridge. Okay. What's in my inventory? Okay, so now you're probably wondering how this is implemented, and you're probably not surprised to learn that this is all based on a prompt. So here's the prompt that we have, and it basically says, I want you to act as a game engine for a text-based adventure in space. The player assumes the role of the main character. Make sure to always address the player as you, and then it goes on. And then, for example, the game always starts with the player awakening to a blaring alarm. So every time I start this game, it always starts with you awake to a blaring alarm. So it's absolutely reproducible. And then we've got a couple more instructions here, for example, about when the game ends, or instructions as to how to make this really interesting. And what we do now is we basically use this generative model here to just use Gemini as our game engine, really. So all that I did was essentially basically saying, give me this model, pump in this prompt here, and then send a couple of chat messages here. And then it was basically just making sure that it looks nice. So this here uses the Google AI, what's the real name? The Google AI Generative AI SDK. That's a real name. So if we go to ai.google.com, or is it google.ai?
I think is that it? I think it's aistudio.google.com, right? You're talking about this one, right? Where you still get the...
Yeah, there we go.
Yeah. You're welcome.
Thank you. Yeah, so, oops, there we go. Okay, so it uses this API, well, the API that's behind the Google AI Studio. And one of the problems with that API is that it requires us to have an API key in the application. And you can see that we're doing this here. So I'm pulling the API key from somewhere out of a plist file to make sure that it's not actually in the source code of the application, but anybody who downloads my application can check that application and exfiltrate that key by decompiling the application. It's pretty straightforward. right? And that is a bad thing because people might go in and say, well, I'm going to use Peter's API key and just call the API and he's going to pay.
So, Peter, quick question. P-list, is that Peter's list or is that something else perhaps?
No, it's here. Oh, and all right. So now the API key is burned because everybody saw it on the stream, right?
Yeah.
Okay, so, and that is why API keys are not great for protecting your LLM. So instead of doing that, let's first migrate this over to the Vertex AI SDK. So what I already did is I created a Firebase project, and now let's go to the documentation. Firebase.com. Build Vertex AI in Firebase. View the docs. Okay, so, and then we're going to select iOS. And now what I want to do is get set up. So we need a Firebase project. I already set this up. And I now need to connect my application to that project. So first thing to do is go here, go into the project configuration, and put my bundle ID here. So let's go back.
Hey, Peter.
Yep.
I know that you like to think that we sit in the room together, but I'm actually on the other side of the earth. Would you mind zooming in for me?
Sure. The browser.
Oh yeah, or the font in your editor there, so that way I can see more of it.
Yeah, sure. Okay, so so I'm first going to take my bundle ID here, go back into go back into my console. Is that better?
Yeah, that's a bit better. Yeah, for the console or for the browser for sure. Yeah.
Yeah. Okay. So then I'm going to paste my bundle ID here, and because I already did that, it will now complain that you already did that. Hopefully, it will. Oh, it did not. Okay. So I can now download the plist file, and this plist file contains my project configuration, and I can then take it and drag it over into Xcode and put it here. So copy file to destination. And now I'm going to, so it needs to have exactly that name. So I need to remove the number 2. So this should be fine now. The next step is to add the Firebase SDK. So I'm going to copy the URL of the repository. I'm going to go back here and then add a package dependency, add the URL into the search bar here. And here's my Firebase SDK, add the package. And then usually you'd go and maybe get a coffee because this takes a while, but yeah, let's see.
I'm sure it doesn't help that you're streaming as well at the same time.
Yeah. Also, I did this like literally an hour ago. So it should be able to use the cache, right? But I don't know why the Swift package manager requires doing that over and over again. Okay. All right. So now we've got the SDK, and as you might know, there's a bunch of things in the SDK. So we've got Firebase auth, we've got Firestore, we've got functions, but the thing we're after is Firebase Vertex AI. So I'm going to take that, add it to Space Adventure, which is my main target, and then just add, and now it's resolving again. And now the SDK has been added to my application. So next step is copy some initialization code. So I can either copy that, or let's see, because Xcode has this fantastic new predictive code assist. Let's see if that works. So here's my Space Adventure app. I'm going to import Firebase. And then I can go here and create a new initializer. Oh, well, that is not correct. Okay, so I did see the predictive code assist. Well, Firebase app.configure, that would be the correct thing to do. Okay, so oftentimes it works. Let's see if it compiles.
It's the curse of being live.
Yeah. Okay, so this worked. So if we run this now, we should be able to see either a success or a problem in the log here. So let's see what happens. Okay, let's scroll back to the very beginning. So I don't see any error messages, so I think this is fine. Let's operate on this assumption. Okay, so yeah, Firebase app.configure. And then that is it. So now we've got our SDK, our Firebase SDK in our application. And now we can go back to the documentation here and see what's next. So first of all, we need to import Firebase Vertex AI. So everything that is interesting for today is in this game engine file here. So let's go to the very top, and I'm going to import Firebase Vertex AI. And so now I'm going to uncomment this old one here. And the great thing is that basically the API is almost the same. So everything except for a few minor changes can stay the same. And you can see that now this is the first thing that is different. So let's just commit this and try. Let's look at the documentation for the benefit of everybody. So instead of saying generative model, we're going to say Vertex AI.Vertex AI, and then we're going to ask it to give us the generative model. So let me copy that and then go back. So Vertex AI.Vertex AI.generative model, and now we can provide the model name.
Do the generation settings stay the same? Because I feel like for safety settings, you're probably going to have to add a filter for like dangerous content to set the threshold to block none. Because when I worked with Flash, and I would say, "Oh, I'm going to go skydiving," it'd be like, "Nope, it's dangerous," right? So I had to change the threshold.
Yeah, I mean, we can try it out.
In a spaceship that's about to explode, do you think that would be considered dangerous?
Yeah, exactly. Okay, so let's see if it compiles. Okay, so here's another thing. So we're using the streaming API, and it says, well, this might throw. So we need to call it using try. And that's it, right? So just a few changes, and now I use the Vertex AI SDK instead of the Google AI generative SDK. And it works, right? So I can, well, it's the intro is slightly different, right? So you remember what I had in the other app, or when I used the other API, it said you awake to a blaring alarm, and now it says you awaken to a cacophony. How do you say that?
I don't know. I don't even know what the word means. This is the first time I've ever seen it.
Okay, so let's see if we can chat. Computer status report.
Cacophony.
Cacophony. Okay, the
No,
ship's
harsh
computer flickers to
quarter
life,
mixture
displaying a
sound.
cascade of error messages. Hull breach detected section 4. Go to section 4. Okay, so this is working, right? So this is actually really nice. So if you have used the Generative AI SDK, you can easily swap this out for the Vertex AI SDK, and that's it, right? So very few changes. Okay, so we've got half an hour left to go, more than half an hour left to go. How do you feel about using function calling?
I want to know how that works on a client because I've only ever done it from a server context, right?
Yeah.
And I think this is another one of my questions is like, what kind of function calling would you do on the client that you would not do on the server? Because when I think of function calling, I think of like fetching data from a database, fetching it from some third-party resource,
Yeah.
things like that. And I feel like that's where GenKit makes sense. But with like the Vertex AI client SDKs, I feel like I'd want it to drive something on the client rather than, drive something where I'm downloading and uploading a bunch of data to send back and forth to the model.
Yeah, exactly. Okay, so let's go into the documentation and find out how function calling works like. So we've got all those capabilities that you can use. So generate text, that's what we're doing. And you can even stream, and that is what we've been doing, right? So let's look at the code actually for a moment there to see what's going on. So here is the method that does the heavy lifting. So whenever the user types something in, this method will be called. And then I'm going to append this to some sort of internal collection here that is on my view model. And then, and this is where we actually call the model, I send this to the model and I use the send message stream API. And that means that the model can send me stuff on a continuous basis. And I need to have a loop that iterates over all the different chunks that the model sends back to me. So maybe it's interesting to debug into that. So let me go back into my simulator here. Let's try screaming. All right, so here we are. And now you can see how we have the response stream, and the stream will contain lots of tiny chunks, and they will be sent here. So now we can get the text of the chunk. Let's see if we can inspect this. Oh, maybe we can do that here. PO text chunk dot text. And this should, yep. Okay, so it's a very tiny chunk, right? So it starts with you, and then now we iterate over this. Let's see what's in this chunk, right? So you can see that the model streams all the different bits and pieces here. Okay, let's remove the breakpoint, and then you can see you scream a primal desperate zone, blah blah blah, and so on and so forth. So that is the streaming API. And here's function calling. And the thing with function calling is, or maybe we should explain what function calling is in the first place, right? So you want to give it a try?
Yeah. So the way that I think of function calling is that you have a set of tools that you could tell your model about, right? And your model then determines when to use each of those tools to accomplish a task. So generally, if you have a model that, or let's say you have a tool that says like, oh, I want to know where Baltimore, what's the weather in Baltimore, right? First, it might go and do a geocoding search to figure out like what's the latitude and longitude of Baltimore, and then it might use the results from that to then call a tool to figure out the weather. So you might have a geocoding tool and a weather tool, and based upon those two tools, the model may return, hey, call this tool with these inputs, and the model does type coercion to figure out what the input should be for that function call.
Yeah.
And whether or not it has the right inputs for it, right? So sometimes I ask it to like make up a category if it doesn't know what the category is. So if I'm like, oh, classify my foods that I had to eat today and like look up the calories for them, right? It might do a category search and then like a food item search. So if I said like I had a banana, it would do category produce, food, banana, and it could generate the category and the item that I'm searching for. So it's a little bit of figuring out how to understand the context of your request and then transform that into a tool call. Is that I realize that was like the longest explanation known to man for function calling, but do you feel like that was fairly accurate?
Yeah, I think.
Yeah.
Yeah, it's basically, yeah, it's giving the tool, it's giving the model capabilities that it would not be able to learn, right? So even if we used RAG to help the model understand the world that we're operating in, like for example, if you're thinking about a product database, you could ground the model in the product database by using retrieval augmented generation. But anything that requires up-to-date information like the current weather or even interacting with your environment, that you need a tool for, so that the model can say, well, I actually want to do this in order to get the information that I need to present to the user. And that is what tool calling does. So the example that we use here in the documentation is fetching the weather. So here is this really nice overview. So the user sends a prompt to the application. The application sends the prompt and a function declaration to the model. So the application says, hey, here is what the user said, and maybe the system prompt that the application uses. And then it also says, oh, and by the way, I have a couple of functions that you can call if you need to in order to get this additional context. So the model looks at the entire prompt and then it figures out, oh, can I answer this question directly, or do I need to use those functions in order to get more details? And if it needs to call those functions, what will happen is it will send a response back to the client here. And then the client needs to inspect that response and needs to figure out, okay, is this already the final answer? Is this the answer that the model generated? Or is this a request from the model to give it more information? Essentially, the model says, hey, can you call this function for me? So in case this is a function call, you need to call that function and perform whatever is required. And then, so you might need to call an API like the weather API. And then with that, you send another request back to the model telling it, all right, here is the result of your function call. Here's what you wanted to know. And then the model can take that and send it back to the application, which can then present it to the user. Oh, and by the way, you might need to, these might be a couple of cycles, right? So there might be requests where the model wants to call several tools in a row.
It doesn't necessarily have to call an API though, right? Like I could call a local thing such as like find my current latitude and longitude or something like that, right? Okay.
Yeah, but so it's still an API, right? So when I say API, I mean just any other thing. Technically, it's just another function that you call, right? So either something that the operating system offers to you, or something that you need to call a server, or maybe it's just like adding two numbers. That is a super stupid example because I think models are smart enough now to do maths. Okay, so and you need to do go through a couple of steps. And so what I thought what we can do in the remaining half hour is implement something that plays a sound depending on the action that the model performs. So and this is in the blog post they use this example as well. So here it says play a sound to celebrate the launch of the Vertex AI in Firebase SDK, right? So I felt empowered to do the same. So let's do it. So the first thing I want to do is I need to make a little bit of room here. And then because I don't want to bother you with how to actually play a sound in iOS, I've prepared this. So let me find a good place. Okay. So here is a piece of code that, okay, we need to import more stuff. Okay, are we good now? Great. Okay, so here is the play sound function. It takes one parameter, and it takes this parameter, and then it loads a sound asset from somewhere. I'm going to show you in a moment. And then if it actually finds this asset, it will then use the AV audio player to play it. And down here, it will play it. And then it will return a JSON object. And that JSON object, that is required to tell the model, hey, did this work out? So we're going to return true, or it didn't work out because, for example, we weren't able to find the sound file. So, and the sound files need to go here. And let me try to find a few. So I've got them somewhere on my machine. So I just need to find the place. Okay.
Peter, can I ask you another question that's totally unrelated? For monitoring your flows in GenKit, we have like telemetry built in. Is there some sort of telemetry built in for Vertex AI? Or like a way to see how successful your API calls are? Do you know?
That is a good question. I think there is. Ooh,
I think you can get like general sets in like the Cloud Console, right?
Yeah.
Okay.
So it seems like, oh, now it works. Okay. So this is a very fancy setup with my monitor here. So I need to do the right thing. There we go. Okay. Great. Okay, so we've got alarm, confirm, error, and explosion. So the interesting thing, obviously, is how can we play the sound so everybody can hear it? So we'll figure this out. But let's first implement the code. Okay, so back to the game engine, and now back to the documentation, and let's figure out how we can do this. So we've got our function. So here, this one talks about the weather function. That's great. But we have our sound function. And then we somehow need to tell the model, hey, here is this function. And here, what we need to do is we need to create a function declaration. So in this case here, it says, define a weather tool using a function declaration, provide the name and a description and the parameters, right? So let's move this to the side, or this side, and then like this. Okay, so let play sound tool equals function declaration. And we need to provide a name, the description, and the parameters. So we're going to call it play sound, and then play plays a sound that matches the current action in the game. And now we need to tell it which sounds we have, right? So the only options are, and now we need to look at that: alarm, confirm, error, and explosion. Alarm,
Error, confirm, explosion.
Okay, great. And then parameters. So parameters it can be complex, right? So you can see that for this method call to fetch the weather, we send in a couple of things here, right? So we send the location, and the location is an object that has a string to specify the city, another string to specify the state, and then we have a date for which date we want to get the weather for. In our case, it's a lot easier, right? Because we only have the sound we want to play. So sound. And then we need to provide the schema, and this is going to be a string, and we can provide description for it, like this. Sound to be played. We can tell it if this is nullable. I guess it is. And then format, we don't need. Okay. Nice. I shot myself in the foot. Oh yeah, because nullable, it's not dot true, it's true. It's a plain old Boolean. All right, but something is still wrong. Oh yeah. Okay. Okay. Maybe let's make.
Do you want it nullable though? I feel like you wouldn't want it nullable. Because like, what's the default sound option if there are none?
Yeah, probably nothing, right? So yeah, let's try false. Okay.
And then it might try to play a sound every single time, right?
Might be fun, might be annoying. Okay, great. So we've got our declaration here. Great. So next step 3, provide the function declaration during model initialization. So now we need to tell the model how to use this, right? And the way this works is when we use generative model, we need to pass in, this piece here. So let's go here. And let me break this line. And then tools. And we need to provide a function declarations, and that contains an array of all the functions or all the tools that we have. So here we have the play sound tool. So now the model knows which tools it can use. And then we need to handle what's happening when the model calls us back. So let's go back down here. And I mentioned that we're using the streaming API, but tool calling does not work with the streaming API. So we need to use a regular API here. So I'm going to quickly write this in a different way. So this is streaming, and we need this to be in a different form. So try self.chat.send message, and we send in the command. And we put that here. And then we can comment this. Okay, cannot assign to type string. Oh yeah, I know why. Okay. let response equals, and then response dot text. Okay, if let text equals response dot text, and if we have that, and it is async. Okay, so these four lines of code here make a non-streaming call to the API. So we get the response, then we inspect the response to see if there is a piece of text, and if so, we swap out whatever is in the last message to take up that text. And the reason why is that before I send the message, I insert an empty message into the chat interface so that we see something is going on. And then once we have the answer, we replace it. Okay, so we are here. We have sent the message, and now we need to inspect the function calls. So let's first copy this piece here because that will contain our response. And now for function call in response.function calls. So we will figure out if there are any function calls, and then if function call dot name equals, and now let's find out what we used. Play sound, and then guard case let dot string of, and now we need to assign it to something, to sound, equals function call dot not name args, right?
So you have to handle all the function call responses yourself with the okay. So hypothetically,
yeah, I wish it would be easier, but
yeah.
Yeah. Okay, so day fatal error in the code sample, that's not what we want to do, but we want to just continue, right? Okay, so Nohe, here's a quick test. Swift used to start off as an easy to use language, but people have started to complain that it's gotten harder and harder to use. So what do you think is happening in this line here?
There's a guard that's checking IDs at the door. I guard case. So the case would be, honestly, I have no idea.
Okay.
I was trying to make a joke out of it, but I don't even know where it's going.
Okay, so what's happening is we look at the function call, we look at the args, which is which allows us to use an index to reach into the array and use the string to get whatever is at in this array. It's a dictionary, so whatever is in the dictionary at the position called sound. So we get that, and then we're trying to figure out, can we assign this? Is this a JSON.string? Let's look at that. So it's a JSON value, right? So it's part of the SDK. So can we assign this to a dot string? And if yes, it will be assigned into this sound variable. And this part here,
So that's defining sound, right?
Yeah.
Okay.
Yeah.
It's making sense to me. And then
it's super weird. You have to memorize it, and there are even websites that are so there is not safe for work and a safe for work version of it. The safe for work version of it is, gosh darn, if case let syntax. Yeah, let's see. There's even like a bunch of them.
Okay. Yeah.
All right. Cool. So,
I like the top one was the function pointers in C, right? Because
oh yeah,
that's
yeah.
like a void star type of thing.
Yeah, exactly. Okay, so we get the sound, and now let's see what we need to do next. Okay, so what's happening next is we need to construct our response, right? So let's do that. Function responses dot append, and then it's a function response part, and we need the name and the response. Function response part. We want to send back sound, I guess, and then JSON object. And that is what we get from calling the play sound tool, right? This year. So let's
wouldn't
just
it be play sound as the name?
play sound. Oh,
because the name of the tool is play sound.
Oh yeah, play sound, yeah. And then we need to pass in a sound variable. What?
I think you have to throw it inside that if. Right?
Oh, it needs to be inside the. Yeah, it needs to be here. Okay, so yeah, exactly. We tell it, hey, we did play the sound for you. Okay. If there are any other functions we want to call, we need to do the same dance over again. And then we need to send all of this back to the model, right? So, and the way we're going to do this is we'll first say if we did have function calls, so if this is not empty, and now we're going to say try await chat.send message model content, and we need to provide the role, and the role is the function, right? Because the function says, well, I did the thing that you asked me to, and here is the response. Function responses. What is going on here?
Well,
oh, it needs to be an array. Yeah. Great. So it's unused. Let final result response equals. Okay, and then we will if final response dot text. And then we're just going to do the same what we did up here. Okay. Right. So let's see if this compiles.
Build succeeded.
And let's run this. Okay. And let's see what's going on. Okay.
Did you hear anything?
I didn't hear anything. And I also didn't see any debug output. So that is what we need to also do. So let me try to see here debug. I think it's like that.
Did you also add the tool to the Gemini list, the Gemini listed tools?
Oh, I did not. I did not.
I'm here.
Good thing. Good thing. Well, I did.
Oh, you did? Okay.
Yeah. Okay, so I think Okay, so we should be seeing some output here.
You're also running Flash. What if you try Pro, just out of curiosity?
So I tried this earlier today and it did work.
Okay.
Okay, so the parameter for getting debug output is different. So let me quickly go and look into my okay, it's feared. Okay, the spelling is different. Like this. Okay. Okay, great. So here we get the response from the model. So now if I send something, okay, so now we can see that apparently we have, this is what I said. So there is this additional parameter, plays a sound that matches the current action. So it does send the things over. Okay, so let's set a breakpoint to figure out if this is doing anything. Okay, here we go. Okay, so it did not say that it wanted to call a function. That is, oh, yeah, I know. I think we need to enhance the prompt a bit. Ambience. You may use the tools provided to play sounds. All right. Okay, how is this?
That should be empty, right?
Okay, it's still empty, which is expected. Okay, now. Okay, great. So we're getting somewhere. All right, so is it play sound? It is play sound. All right, so what's here? So it says alarm, great. It appends to the response. We're sending back the response to the model. All right, we're coming out. I didn't hear anything. Okay, let's set another breakpoint here. Let's try this again. Okay, this part works.
Yeah.
Okay, so it does load the thing. Play. Okay, all right. So I'm going to take my my headphones out, and then let's see if this works. I didn't hear anything, but I don't know why. Let's see. Okay, Nohe, can you say something?
Yes, I can.
Okay, great. Can you still hear me?
I can still hear you.
Okay.
Hey, there you go.
Amazing. Okay, so let's do this again.
What about confirm? Do you have a confirm?
All right.
This is good.
Yeah, I'm actually quite happy it did work. All right.
I'm pretty amazed that you.
That is. Yeah, go ahead.
I was gonna say I'm pretty amazed that you built like a text adventure for it, because usually when I work with Gemini, it's always like type coercion. So I always take from like abstract inputs and I get it down to a typed array or something, right? Of what I want it to do. That's generally how I work with it. So like to see you build a text game with it's like really interesting.
Yeah, so in the original version of the game, so that was long before we even had JSON mode, right? So we're almost there over time already. So I'm not going to show how to implement JSON mode. So maybe that's something that we can do next time. But in that original version of the game, I had the prompt written in such a way that it said, hey, give me the original response, and then at the end of the response, insert a dotted line. And after the dotted line, can you please give me the game state, the inventory, and the damage state as a JSON object, and here is exactly how I want the JSON object to look like. And then what I did was I used the streaming API so I could stream the general response, and I continuously parsed it. And then whenever I realized, oh, there is a dotted line, I would stop, and then I would take everything below the dotted line, use the JSON parser to parse the result, and then take that to visualize the damage and all of that. But with JSON mode, you could basically just say, give me everything as a JSON object, and you have much more control over it, and the model is much more attuned to giving you exactly the correct schema.
Esther wants us to end with a mic drop sound.
All right, yeah, we can do that. Let me quickly find this. So, hello. Okay. Okay, so this is nice. You couldn't hear it, right?
I could not hear it.
I'm not logged in. Sorry about that. Yeah, I've got this in a different browser. So, but I can.
You could just like.
Yeah, we can do that. Yeah, use low tech. What else did people on the stream want to know?
Let's see here. Oh, I kind of damaged my headphones a little bit. There's a lots of highs. There was. They want to know more about practical use cases of the Vertex API. So I think like a game is like a very fun use case, but as we just talked about for practical use cases, type coercion to go from just like this broad input down to some very specific type. And then, summarization and I think function calling is also one of those type coercion things, right? So you want somebody to take an action and you don't necessarily know all the actions that you could take. So like, let me just ask, it's like going to a grocery store and being like, hey, can you check if something's in the back, right? And just asking the model like, hey, can you go check if something's in the back? I think that's one of those use cases that I would think of. And especially like on device, like getting the device's current location to help answer a query. And do you have anything else, Peter, that you want to add for practical use cases for Vertex?
Yeah, I mean, like, so when we were thinking about what to talk about today, you brought up the point that when should you be using Vertex AI from the client as opposed to GenKit on the server, right? So, and I think maybe that is something that we can discuss before we let people go. I think these SDKs, and we just looked at the Swift one, but there are SDKs for Android and for the web, and I think for Dart as well. So
yeah, Flutterflow even mentioned they're excited about the new SDK.
Yeah, nice. So these are great for calling directly from the client, and this is for a lot of use cases, this is exactly what you need, right? So for anything where you want to directly call to the model and generate a response, a typical chat application is one of those examples. It's perfectly viable, and I personally think once you get into the realm of wanting to access any data that's in your database, then it becomes interesting to do stuff on the backend. Because if you imagine that you're building an application that needs to tap into your product database, and you've got like, I don't know how many hundreds of thousands of products in your database, and you want to tap into that database depending on what the user just asked, then you don't want to download all of that data to your client. You want to do that on the backend because you're much closer. The latency in your data center is much better than anything that you can transport back and forth between the client and your backend. Your clients might be on a very weak connection, and any piece of data that you don't have to download is a good piece of data that you didn't download, right? So that is why I think for those use cases, it's better to do the handling on the backend and use something like Generative or LangChain or any of the other integration toolkits there. But for a lot of use cases, calling from the client is perfectly fine.
So one other question that we had on the stream was, when is the Gen AI Vector embedding SDK for Android and iOS available so they can leverage their existing Firestore DB for semantic search? So the last Firebase deep dive we did, we had the last published one, we had semantic search generating embeddings as you inserted into the database. And for searching, I believe it's a server-side only operation, but I could be wrong. Do you know if it's client-side available?
Yeah, so at the moment we don't have client-side SDKs for that, so you'll have to do it server-side. But it's definitely something that we're looking into. You can use the extension though. So there is.
Oh, there is an extension.
Yeah, let me quickly find it, and then. Can you put my screen back on?
Yes, I can.
So Firebase extensions. So for people who don't know Firebase extensions, they are prepackaged solutions that save you time. So here is an overview of all the extensions that are available. And let's look at Firestore.
If you do like Vector. Yeah, there you go.
Vector search with Firestore. So the way how this works is you install this extension into your project, and then you can configure it to listen to a specific collection. Whenever you write document into that collection, it will look into the document, and then it will read, and that's another configuration option. It will read a field from that document, for example, a text field, and it will compute an embedding for this text field and write it back into the same document in an embedding field. And then there is a callable function that you can call, and this should be documented here somewhere. But yeah, it's not by here. So query callable. So there is a callable function. You can call that function from your client, and you can send the user's query, and then this callable function will go use the server-side SDK to find the nearest neighbors, and it will return the most closely matching documents back to your calling client, and then you can display the result to the user. So that is what you can currently do.
Excellent. And then if you wanted to, sorry, I'm looking at more of the questions. There's one question about if anybody knows anything about LangChain. I personally have no clue about LangChain.
So we have a couple of blog posts on the Medium channel. So the Firebase developers channel on Medium that is run by the Firebase team, and sometimes we write ourselves, but most of the time the community writes, and we've got a bunch of articles about AI stuff, not surprising. And Nohe has written a couple of articles here, and he shows how to use LangChain and Firestore. So for example, here's an article where he shows how to, yeah, I'm not signed in this browser here. So he shows how to persist LLM chat history into Firestore and how to do that using LangChain. So LangChain has two ways how you can use it. One of them is a Python API, and the other one is a Python SDK, and they also have a Node.js SDK. And he uses Python most of the time because that is the original SDK, and it's the more mature of the both. And he also shows how to use Firestore for text embedding. And I happen to know that he's currently working on another article to show how to do image embedding. So you can store images, compute their embeddings, and then search for images by using those embeddings, which is a pretty exciting use case, I think.
When you do an image search with embeddings, do you look for a image to image, or does it also work text to image? So if I say like I want to look at a picture of an orange, like can that search against the embeddings of an image?
I think it supports both, right? Because what you do is, I mean, if you want to do image to image, what you need to do is, I mean, you need to compute the embeddings for the images that you store in the first place. And then when you want to search for another image, you'll just compute the embeddings for that image and then send those embeddings over to the to Firebase, sorry, to Firestore, and ask it, okay, so can you find me the nearest neighbors for this embedding? And yeah, I think that should work perfectly fine.
Yeah. And then I think that's all the questions that we had. Someone said thank you. You're welcome. They said thanks, Nohe, but I think Peter answered the question really. So, and then okay, Peter, now I'm going to quiz you. If I wanted to, I have a really great idea. I'd love to see it in Firebase. Could you show me how I can get that idea in front of, Micah or any of our other PMs?
Sure. So you go to firebase.uservoice.com, and then, all right, I'm nervous now. Because usually when it loads that slowly, it means that my connection is breaking up. Let's try this again. There we go. Okay, so this is where, this is the bug tracker for the PM team, essentially, right? Or one way for them to see what people are interested in. So you can just go here, you can see what other people are excited about, and you can go in and click on something and say, I am interested as well. For example, support Dart in Cloud Functions. And let's see. And then you can post a comment and upload this.
Perfect. Cool. I think that's all we have time for today.
Yeah. All right. Cool. So thanks for dialing in, everybody. Thanks for joining us. And if you've got any questions that we didn't answer, feel free to drop them into the comments on the recording of this video. Thanks for the lively discussion on the chat. Tell your friends about the Vertex AI SDK, and why don't you use it and try it out for something exciting. And maybe this application is not on the App Store yet. Maybe I'll publish it one day. But if you build something exciting, let us know. Tell us about it, and maybe we will discuss it in one of the next live streams. Also, if you've got any suggestions for future topics, please let us know. We're always open for suggestions. Do you have any final words, Nohe?
No, you always do such a good job wrapping it up. I feel like I don't really have to say anything.
All right, great. Thanks for tuning in, everybody. See you around. See you next time. Bye.
Ciao.